This is our flipped classroom lesson for the vertex form of a quadratic equation. And so you need to follow along in your notes and pause the video when you're supposed to so you can be working out some of these problems and then come prepared to class. So first of all, pause the video and do the two warm-ups. You're just completing the square to solve the quadratics, and then start the video when you're ready. Okay, number one. This is how it works out. So you should have x is equal to 6 plus or minus the square root of 43. And so you can pause and look at the steps if you need to there. For number two, you'll get x is equal to 2 plus or minus the square root of 23 halves. And just notice that right here, I really subtracted 8, so I'm going to subtract 8 from the other side. Okay, so what we're going to be doing today is we're going to be looking at the different characteristics of a graph and finding out some things about the graphs. And so we're going to start with looking at your problems 1 and 2 in the warm-up. We're going to use those equations. And so we're going to do these different things. We're going to describe the transformations, so how does it get from the parent function to what it is. We're going to name the vertex. We're going to state if it's a max or a min. We're going to state the domain and range. And then we're going to solve to find the zeros, which means the x-intercepts as well, same thing. We're going to state the y-intercept and make sure we're going to use exact numbers. Okay, so what I've done is just rewritten the equations from 1 and 2 above from the point in the warm-up where you came up with what's called the vertex form. And it's called that because you can tell by looking at the equation what the vertex is, and you get there by completing the square. And so you'll notice that, we used completing the square, and so we got to this format of each of the equations. So I'm going to just take one of them at a time and go through the different things that we're supposed to find. Okay, so starting with the first one, the first thing we're supposed to do is describe the transformations. And so the minus 6, that tells me that we're going to go right 6. And then the minus 43 tells me that we're going to go down 43. And so that's the transformations of this graph. Okay, the next thing is B. We're going to name the vertex. And so the vertex is going to be positive 6 and negative 43. And we get that by looking at those two things right there. Okay, C is it a max or a min? Well, I know that since there's no reflection, I can tell because there's no negative number right there, it's going to open up like this, and so it's going to be a min, so minimum. Okay, and then D, it says state the domain and range. So in quadratics, the domain is always all real numbers, so we're just going to state that as an interval from negative infinity to infinity. The range, because the graph, and I know from looking at what I've done before, is that the graph, it's going to be the vertex is 6, negative 43, so it's going to be like this. So the bottom point right there, that's going to be negative 43, so it's going to go from there to infinity. So the range is going to be y is an element of as low as it goes is negative 43, and that is inclusive to infinity. Okay, and then the next thing we're supposed to do is we're supposed to solve to find the zeros. So I'm going to actually erase what I have here so we have some space to work. And so to solve, we're just solving the equation like what we've done before. So we're going to take this and we're going to say, well, to find the intercepts, we're going to let the y equal 0 because I want to know where is it crossing the x-axis. That's what I'm looking for. And also, when you are finding the roots or the solutions, remember that that's how we do it with the quadratic formula and so on. Because of the form that this is in, we're not going to use the quadratic formula because that would just be extra work. So I'm going to add 43 to both sides. Then I'm going to take the square root of both sides. And this is actually what you did in the previous, in the warm-up question. And so that means x is equal to 6 plus or minus the square root of 43. So what you did in the warm-up when you solved the equation, when you solve it, you're finding the solutions, you're finding the roots. So this is the answer to part E. Okay, the next thing we're going to do is we're going to find the y-intercept. Now, just like with the x-intercepts, we let the y be 0. With the y-intercept, we let the x be 0. So this is actually the easiest one to do because all you're going to do is you're going to find when x is 0, what is y? So you just put 0 in for x, and so we've got 36 minus 43. And so y is equal to -7. So that means my y-intercept is 0 because that's what x is, and -7. That's my y-intercept. So that's the answer to F. Okay, and we just always want to make sure we give exact answers unless we're told to round. Okay, now we're going to go to number 4. Oh, sorry, axis of symmetry. What the axis of symmetry is when you are graphing your equation, and if we have, this vertex, just say we have that, wherever the vertex is, that's going to be your axis of symmetry. So whatever the x value is for that, that's going to be your axis of symmetry. So on number 3, since my vertex is at 6, -43, at the point +6, we're going to have a vertical line going through, so my axis of symmetry is just the equation x equals 6. And so the axis of symmetry is really easy. All you have to do is just write what x is. Okay, now let's go to number 4, and we're just going to go through the same process. Just note that since we already solved it back up in the warm-up, I already know what the answer to E is. We've already found the zeros, so I already know that. So what we found up and above was 2 plus or minus the square root of 23 halves, and that's your E. So I'm going to skip that part when we get there. Okay, so the first part of this is to describe the transformations. The negative tells me I have a reflection. The 2 tells me that we have a vertical stretch. And that's a stretch times 2, so it's twice as steep, so to speak. This -2 inside the parentheses tells me that we're going to go right 2. And this plus 23 tells me we're going to go up 23. And so that's when I say state the transformations, that's what I'm talking about. Okay, the next thing, part B, is name the vertex. And so the vertex is 2, 23. And so that's a vertex, that's part B. Okay, C, is it a max or min? Well, since it's being reflected, it's going like this, and so I know that that's going to be a max. So part C is a max. Okay, D, the domain and range. Remember that with quadratics, the domain is always all real numbers. So the domain is x is an element of -infinity to infinity. Okay, the range. How low does it go is the first thing we're going to say. So it goes down to -infinity. And how high does it go? That's the vertex. And so it's going to go up to 23. It will be inclusive. Okay, we've already done E. And so then the last part of this is just finding the y-intercept. And let me erase some of this here. Kind of have a mess. With the y-intercept, we're going to let x be 0. And so I'm going to say y is equal to -2 times 0 minus 2, quantity squared plus 23. And so then we're just going to work that out. And so y is equal to 15. And so it's x is 0, y is 15, and that's my y-intercept, so that's F. Okay, and then the last part that I've added down here is write the equation of the axis of symmetry. And so since my vertex is at 2, 23, the axis will go through the x coordinate, so it's just going to be x equals 2. Okay, so now we're going to go on to the next problem. So on number 5, and I give you this equation, and we're going to do kind of similar types of things. So remember that g of x is another way to say y, and so all I did was right here in A, I just restated it because it was already in what we call vertex form. So vertex form of an equation, basically it is y is equal to A, and that's going to tell us about the reflection in the stretch, times x minus h, quantity squared plus k. And if you remember from when we did circles, hk is the center. And so remember that hk, we did that when we did circles, that's the center. And then the A tells us about the stretch and the reflection. So if it's in that format, then it's easy to graph. We can tell what all the transformations are, and we can tell a lot about the graph. And so that's one of the reasons why completing the square is really important and really good to know, because it helps you get your graph or your equation in a way that you can graph it easy. Okay, so for part B, we're going to give the coordinates of the vertex, and so that's going to be 3 and 4. So remember the 3 comes from there and the 4 comes from there. Part C, the equation of the axis of symmetry. So remember that that has to do with the vertex. So if we're looking at the vertex, which we just put right there, then what does that tell me about the axis of symmetry? Okay, so it's going to be x is equal to 3. Okay. D, describe the transformations. And so here's where we're going to say all the things that we know because of this. I'm going to kind of do it over here so I have space. That right there is going to tell me that there's a reflection. The 2 is going to tell me that there's a vertical stretch. And I'm going to write times 2, and I'd like you to do that too, because then you're telling me that you know how stretchy it is. This is going to tell me that it's going to go right 3. Remember, insiders lie. And then this is going to be up 4. And so there can be, that many transformations that you could state. Sometimes maybe you only have one transformation to talk about, and sometimes you have as many as 4. Okay, D, we're going to just, oh wait, that was D, sorry. Okay, and E, write the y-intercept, so we're going to let x equal 0. So you're just going to plug in with -2 and then 0 minus 3, quantity squared plus 4. So just solve it and find out what y is equal to. So we're going to have -18 plus 4, so -14. So x is 0, y is -14. And that's your y-intercept. Okay, now going on to number 6. Okay, if you want to pause the video and see if you can do this, and then turn it back on and see if you were right. Okay, the first thing we're going to do is we're going to just rewrite that in vertex form, so we will have to complete the square. So what you should have done, factor out that negative, because there can't be a negative coefficient if you're going to complete the square. So we're going to take out a -1. So then you'd have to watch your signs right there. We're going to add 4, but really what we did was we didn't add 4, we subtracted 4, so I'm going to add 4 back. And so you've got to make sure you've got the right vertex formula, or form. So if you didn't have that, you'll need to change what else you have. So that's going to be my equation. B, give the coordinates of the vertex. That will be 2, 4. C, write the equation of the axis of symmetry. So that has to do with our vertex, so this number right there. So x is equal to 2. Okay, D, describe the transformations. So what's happening? We have got a reflection. Now if it says 1, that doesn't mean a stretch or a compression, so it's just the same, it's just reflected. And then we're going to go right 2 and up 4. Okay, and then last we're supposed to state the y-intercept. That's where we let x be 0. So you're going to plug x or 0 in for x, and then you get 0. So that's how you're going to get your y-intercept. So that's actually both the x-intercept and the y-intercept. If you solve that equation, that would be your solution as well. Okay, next one, number 7. This kind of gets a little bit intensive, so it's going to take a little bit of time to do the problem, so bear with me. The first thing we need to do is we need to take this equation and we need to write it in vertex form. So basically it means you're going to need to complete the square and get it into the format where you can tell what the vertex is, and so we'll complete the square to do that. So we are going to leave some space, so I just put these first there, and I left some space to complete the square, and then I put the -14 right there. I'm going to add 9. Half of 6 is 3 and squared is 9, so then I'll take away 9 because I'm still on the same side of the equation. Now write this part as a perfect square. So y is equal to x minus 3 quantity squared, and then -14 and -9 is -23. Now that's in vertex form. Okay, and then part B, the first part of 7, it says find the y-intercept. And I forgot to leave space in the box to the right, so we'll just write it right here. So the y-intercept, you let x be 0. And so plug it in, and you find out y is equal to 14. And so my y-intercept is 0, -14, right there. And then my equation right there. And then part B, it says give the coordinates of the vertex. So 3 comes from there and -23 from there. So pay attention to the signs, and if they're going to be positive or negative, remember if it's inside the parentheses, you're going to go opposite sign. Okay, part C, the equation of the axis of symmetry. Again, that's based on that number right there. So it's going to be x is equal to Okay, whoops, I don't know where that came from. That would be x is equal to 3, and that's our axis of symmetry. Okay, next, D, describe the transformation. So talk about how it's moving. And so there's no reflection, there's no stretch. It's just going to move right and down. And so you'll say that. Okay, E is name the real root. So you're going to need to take this equation, and so take it from vertex form, and you're going to solve that. So you're going to let y equal 0, and you're going to solve this equation for x. So when you do that, you'll have these steps. I know I'm going fast, but I'm just trying to make the video not too long. You can always pause it to take more time. So move the 23 to the other side, take the square root of both sides. So you have x minus 3 is equal to plus or minus square root 23. Put the 3 on the other side. So your solutions are 3 plus or minus the square root of 23. Okay, now keep in mind what that means. That means that if I was to graph this, these are my x-intercepts. So if you got a decimal approximation for 3 plus the square root of 23, you know, over here somewhere, and then if you do 3 minus the square root of 23, it's going to be, you know, over here. So that kind of tells you something about it. You also know your vertex is 3, negative 23, and you know where your y-intercept is. We already figured that out. It's at 0, negative 14. So there's a lot of information there about the graph that you can tell if you needed to graph it. Okay, F, the interval where the function is increasing or decreasing. I should have left that picture up. So if you've got this picture, where is it increasing? So it's going to start here and it's going to start increasing there. So that's the interval. Well, where does this start? That's starting at the vertex at 3. So my increasing picture is going to be the 3 to infinity. And then if you look at your graph, where is it decreasing? It's decreasing from negative infinity until here. So remember that when you're doing this, you're talking about, you know, where are you walking along the x-axis when it's decreasing? So as long as you're right here, up to that point, it's decreasing. So from negative infinity to 3, it's decreasing. Once you get to 3, then it starts increasing as you walk along. So that's 3 to infinity. And so it's kind of a weird thing because you have to think about walking along the x-axis, but you're looking on the y-axis for the height as well. So if you need to pause and take a second and think about that, then that might be a good idea. Okay, the last part is state where it's positive and where it's negative. So if, let me erase some of this stuff. So if on our graph, if we look at where is the graph positive, I'm asking where is it above the x-axis. So again, think about walking along the x-axis. If I'm over here, the graph is positive. See, it's going to be up here somewhere. And if, as I walk along, at this point, it starts being negative. And then it's negative until I get to this point, and then it starts being positive again. So my positive interval is from negative infinity until this x-intercept right there, and that's going to be the 3 minus the square root of 23. And then it's going to pick up again at 3 plus the square root of 23, all the way until I get to infinity. So writing the intervals, the positive interval, hold on. Sorry, just noticing I copied this wrong, obviously. So the positive interval, as I just said, is going to be from negative infinity to 3 minus the square root of 23. And then the negative interval is going to be x is an element of from 3 plus the square root of 23. Hold on. Ugh. Okay, continuing on with the positive, we still have another positive. It's also picks up at 3 plus the square root of 23 until infinity, like I just showed you on the graph. So if I have the graph, it's positive here, so as you're walking along from there to there and from there to there. Where is it negative? It's negative between these two spots. So what I'm going to write for my negative is it's going to be negative as long as x is between 3 minus the square root of 23 until you get to 3 plus the square root of 23. And that's where it's negative. Okay, so for 8, I'm going to go ahead and go through this. I'm also going to have a copy of these notes on the website, so if you'd rather not watch the video but you can work through it and then just check your answers, that's fine. But if you need some explanation, then you need to continue watching this. I'm going to take 8, I'm going to write that in vertex form, so the first thing I need to do is factor out that negative 3. So I'm going to take the negative 3 and factor it out, so I'll have negative 3 times x squared plus 3x. I'm going to leave some space. And then really what I did was I subtracted 27/4. That's why I'm adding 27/4. And then I just wrote plus 10 as plus 40 over 4 to get me a common denominator. Okay, so now rewrite that in vertex form. And so that's going to be negative 3. Half of 3 was 3 halves, quantity squared, and then 27/4 plus 44 is 67/4. Okay, that's part A. Okay, next we are going to give the coordinates of the vertex, and so that's, oh wait, we got to do the y-intercept. So what I did was I just put 0 in for x, sorry, yeah, for x. And so right here is 0, and solve it, and I get 10 in the end. So that means that 0, 10 is my y-intercept. So pause if you need to look that over. Okay, now we're on to part B, the vertex. And so the vertex is coming from that negative 3 halves and the 67/4. And then the next thing we're going to do is the axis of symmetry. And so that's the x equals negative 3 halves. Okay, next is describe the transformations. So the negative tells me it's reflected. The 3 tells me there's a vertical stretch 3 times as fast. It's going to go left 3 halves and up 67/4. Okay, and then the next thing we're going to do is name the real roots, and so that's where we solve the equation. So I'm going to go back to this version of it, the vertex form, and I'm going to set y equal to 0. And then I'll solve that by getting, x on the side by itself and take the square root of both sides and so on. So I'm just writing out my steps here. You, of course, can just do it and then play the video again. Okay, so these are my roots. Now think about what that tells me. That tells me that when I graph this, it's going to add negative 3 halves plus the square root of 67/12, whatever that decimal happens to be. You can approximate what that is. I'm not even really sure what it is. And then negative 3 halves minus square root of 67/12. And so I know that it's going to be opening down, so it's going to be looking like that. It's going to have a max in case I'm being asked about that. The range will be from negative infinity to positive 67/4. So even though I'm not asking those questions, you would be able to tell me about those questions. You'll also need to think about that when you do the other parts of this problem. So on the next one, state the interval where the function is increasing or decreasing. Let me erase some of this and I'll go through real quick how to do that in case you need me to. Just making some space. So if I was to graph this again, I know that my intercepts are at, somewhere over here and I think somewhere over here, and it's opening like this. So where is it increasing? It's increasing from here to here. So from negative infinity until I get to this point right here, which is the vertex, so negative 3 halves. And so that's going to be my interval for increasing. My decreasing interval is going to start right there and going down, so that means starting right here until I get out there, it's going to be decreasing. So that's how I'll write that. So my increasing, this is where it is. Sorry, we're kind of squished in here. That's how you're going to write that. Then the last thing we're going to do is we're going to look at the graph again, and we're going to think about the positive and negative parts of the graph. And so let me just sketch that again real quickly. Okay, we're going to have something like this. So as far as the positive and negative parts, this part is positive, so between the two roots, so between the negative 3 halves minus square root 67/12 and from negative 3 halves, other way around. This is negative 3 halves plus the square root of 67/12, and this one is negative 3 halves minus the square root of 67/12. So that's going to be my positive part. The negative part will be here. Okay, so if you think about walking along the x-axis from negative infinity all the way until I get to here, that's going to be negative. And then when I get to this point, until I get to positive infinity, that will be negative. Between these 2 points, walking along this part right here, that's where it's positive. So the way I'm going to write that is like this. Okay, so this is where I'm writing that. Okay, so what I'm suggesting on the last one is just pause the video, work out the problem, and see if you can get it right, although I do want you to listen to the first part of it, and then you can just compare all your answers. So in the next one, I want you to notice how this is written. We're going to talk more about this form later, but this is called Intercept Form. It's not Vertex Form, it's Intercept Form. So before we multiply it all together and everything, let's take advantage of what it tells us. If we look at what we already know about this, we know that if it's written like this, I know my solutions. It means that either 3 is equal to 0, or x minus 2 is equal to 0, or x plus 1 is equal to 0. So that means x is equal to 2, or x is equal to negative 1. I just found my solutions. So I can put that in right there for E, where I am going to name the real roots. So I've got that part. So use that before you put it into vertex form. Now you're going to multiply everything together, complete the square, put it in vertex form so that you can tell the other things that we need to know. So right now you can pause the video, or if you feel like you're not really sure, then maybe you want to watch it. I'm going to not really spend a lot of time talking about it, but go through it kind of fast. So here's the steps to complete the square and multiply everything through. So this will be part A. And so with that, I can tell what the transformations are. I can tell what the vertex is. I can tell what the axis of symmetry is. I already know the roots, and so I've already gone through part E with just completing the square. I can tell everything else. The y-intercept, that's easy. I just let x be 0. And actually, if I go back to the original first step, I can just plug 0 in right here and do it that way. So my y-intercept is 0, negative 6. And again, I don't have anywhere to put that, but that's how you would find that. Okay, the vertex is 1/2 negative 27/4, and the transformations, the axis of symmetry, x equals 1/2. You do have to write that as an equation because it's a line. Here are the transformations. Okay, and then I've already found the roots or the solutions, and so thinking about the graph and how that looks, that means that my graph is going to be looking like this. That's where it's going to cross the x-axis. I can tell because this is positive or because this is positive that it's going to be opening up like that. And so that's going to help me find the next parts of this, stating the intervals where we've got increasing and decreasing. So make sure that you can do that. Okay, so the increasing interval is going to be from 1/2 to infinity. So that's the yellow part that I've got on the graph. And the decreasing interval is going to be from negative infinity to 1/2, the green part of the graph. Okay, the next thing is the positive and negative parts. So if I look at my graph, the positive part's what I've highlighted in red. So think about it as you're walking along the x-axis from negative infinity until you get to this point right here, that's going to be positive. Then it will be negative for a while, and then once I get here, it's going to be positive again. It's in between here that it's negative, so that's how I write my intervals. So notice that for the positive, I have 2 intervals that I had to write, from negative infinity to negative 1, and then from positive 2 to positive infinity. And then the negative interval will be x is an element of negative 1 and 2. Okay, so that takes care of the lesson. You're going to need a little bit of time to think through it, and we'll be doing practice in class. We'll be able to answer some questions, but make sure you come with all of this done.